Hello, everyone. I'm Alan Knight. I'm the program chair for Smalltalk Solutions, and I would like to welcome our first invited talk for this conference, Gilad Bracha. I hope I'm pronouncing that roughly right.
No.
Which is why I will let
you do hope. It's true.
Which is why I will let him introduce himself.
So it's Gilad with a hard G. The rest I don't even attempt to correct. Generally, if you say it like Alan said it with a hard G, that's as close as you can come, unless you're from the country that can say sounds like and things like that. Can you all hear me? Because I don't feel like being tied to this thing. Can you hear me in the back? If you're listening. If you're not listening, it's fine. So yeah, I'm a one-time Smalltalker, or used to be at some point. I used to work at an outfit called Anamorphic Systems that did a fast Smalltalk VM that you might have heard about once upon a time. And then the world changed in a rather sad way, and we were acquired by Sun and for VM technology, which now runs Java virtual machines everywhere, more or less. So I spent 10 years in intellectual prostitution, maintaining the Java language and virtual machine specs, and now I'm doing a new project, which is a lot of fun, which is a new programming language and platform called Newspeak, which is directly descended from Smalltalk, and I hope might be of some interest to you. So you're probably thinking, first of all, what gave this guy the nerve to go and muck with Smalltalk? You know, how do you get the sheer gall, the unmitigated arrogance to go and tamper with such a really enormous intellectual achievement? And so I'm here to explain myself. So, as many of you probably know, this is the Barcelona Pavilion, which was designed by Mies van der Rohe in 1929. And the reason I'm showing it here is it's the Smalltalk of architecture. It is a brilliant composition of very, very simple pieces. Modernist architecture gets a bad name because very often what you find is a box. Because working with a minimalist palette is hard, and doing something good with minimalist, with very few elements is much harder than doing it with a lot of complicated bells and whistles. Anybody almost can go and create a working programming language by lobbing in features, and many people do. Smalltalk is different. Smalltalk is just it's like this. It's beautiful because it's made out of very, very simple elements. What you got here basically is a bunch of boxes, and most people given a bunch of boxes turn out more boxes, and Mies van der Rohe is a little bit different. So how is this relevant? Well, even though this is a beautiful building, if you actually wanted to use it for some practical purpose today, well, guess what? It's highly unlikely that it has a broadband internet connection, for example. Right? I don't think that they really thought about that in the 20s. And so what would you do if you wanted to hook up broadband internet here? Well, you need either DSL or cable. So that's when the cable company, there's probably a pole over here someplace. So they'll string this nice black cable, they'll drill a hole in these beautifully matched travertine panels, then it'll go sort of string it along like a millipede along this white expanse of ceiling and stuff. And, you probably don't want to do that. So you do have to be careful when something is composed this carefully and designed this carefully. It's very easy to mess up, and you do have to be very careful. And I'm telling you this, I'm aware of that. Nevertheless, the fact is that things occasionally have to be updated or adapted as circumstances change. And that's essentially what we're trying to do with Newspeak. So here's another picture. I just couldn't resist having another picture of this stuff, right? This is all made out of these rectilinear shapes, right? But there are different materials and textures. There's travertine, there's glass, there's marble, there's concrete. It's easy to, it looks simple, right? But it's incredibly difficult to put this together. And so I'm telling you this because I have an enormous amount of admiration and respect for Smalltalk and how it's been done. And I've loved it since the first moment I saw it, which was a long, long time ago. Not as long as perhaps as maybe some of you, right? I didn't have the privilege of encountering it like in 1980. As far as I can remember, encountered it in 1984. And I guess that was karma because, you know, the beginnings of Newspeak are in 1984, and so it had to be that. Oops. So, the point is that things have changed since 1980 when Smalltalk was designed, and there are some things that could be adjusted. So the environment, the world has changed a lot since 1980, and we've also learned a little bit over 30 years in computing about things. So a few things that have changed, some of them recent, that might have affected the design of programming languages, the whole issue of multi-cores, and this internet web thingy that Al Gore invented, or whoever it was. And what we've learned, we learned very little actually, but what we have learned, we've learned, for example, that security is a big deal, right? They weren't thinking about these wonderful viruses and worms and malware and spam and all this lovely stuff that now pervades the computing environment. We've learned that modularity is very important. Most languages today have incredibly lame modularity constructs that are pretty much directly descended from things that were leading-edge research around the same time that Smalltalk was developed. And they clearly don't work very well, just as the security measures we have in place today clearly don't work very well. We've learned that ecosystems matter, and I'm not talking about global warming. That was the one and only reference to Al Gore. What I'm talking about is computing ecosystems, right? The fitness function, for example, for a programming language, as you are no doubt painfully aware, has very little to do with how good the programming language itself actually is. It has to do with how it fits in with a larger environment, with the things it has to interoperate with the people it has that have to use it, and the economics and all kinds of things. And so if we relate that to Smalltalk, we find that it isn't quite perfect. Here are the three imperfections that I'm going to be talking about. Smalltalk is not that secure. It wasn't designed with security in mind. It was designed, on the contrary, to be open and malleable and to make everything accessible so everything can be changed and be very flexible and in the goal of knowledge and education and all these things, right? But the spam kings don't care, right? They're the scum of the earth, and it's an environment that will take advantage of that to do bad things, and scum is one of the world's natural resources that we have in abundance. And so Smalltalk doesn't deal with that very well. Modularity. So some of the constructs that you might see in your average vanilla programming language today, whatever they're called, packages, modules, whatever name is attached to them, you know, they come from the research in the 70s, Clue, and some stuff that was done right next door to Smalltalk, Mesa and Cedar. There were people experimenting with things like that, right? Smalltalk in particular did nothing about this. You know, most languages have some, however lame, excuse for a modularity structure. Smalltalk doesn't bother. So there's homebrewed solutions as well. Different vendors here have their own mechanisms. There's nothing standard. It doesn't work very well. Doesn't work very well in other languages, but actually I think Newspeak has a contribution. The third problem is interoperability, right? So, coming from Smalltalk, why would you want to interoperate with the scum, right? I mean, why do you don't really want to stick your finger out there and see what's there, but the fact is you have to. And the mechanisms in most Smalltalks leave a lot to be desired. That has to be made really easy and simple and understandable. And so now we're going to get gradually a little more technical, and we're going to talk about the differences between Newspeak and Smalltalk, and eventually we'll relate them to these particular issues. So what are the differences? There's three major differences. There's a lot of little bells and whistles, not that many really. The important ones are here. It's a message-based language, and I'll explain what I mean by that. There's no static state whatsoever, and classes can nest. That's sort of the short story. So what do we mean by message-based? You might say that Smalltalk is message-based, right? We have these objects. They always communicate via synchronous message passing. And so what's not message-based? Well, we'll see in a moment, but obviously people who know Smalltalk aren't convinced that it's message-based, right? Alan probably does know Smalltalk. So I assume my interpretation is the same as his. I have to verify that. So we want message-based means everything is a message. Everything you do during computation is a message send. Everything. So if we look at this piece of code right here, Smalltalk code, all the stuff in red is not a message send. The stuff in bright red, they're all variables, variable references, and then there's assignment, which is anything but a message send. So clearly there's a lot of things you do in Smalltalk that are not message sends. Now,
I disagree. The implementation of the assignment is a message.
Hell it is. But anyway, we disagree. We will get there. If you actually wanted to write things where all these variable accesses were message sends, it would look something like this. And there's a lot of stuff there that's kind of verbose. And in fact, the idea of doing a language where everything is a message send is not my idea, and it's not new. It's been done before. It was done in Self. And in Self, they also realized that if you actually take this idea seriously and make everything a message send, then this notion that Smalltalk has that you explicitly write the receiver, it doesn't scale very well syntactically. It just becomes very burdensome. And so they decided to have implicit receivers, right? Now the idea of having an explicit receiver from a language design point in Smalltalk works beautifully. It really simplifies a lot of things. Again, it's part of that minimalist ethic of not putting in too many bells and whistles. However, it only works because there are a lot of things that are not message sends. And so if you do this in Self, you get something like this. In Newspeak, you might get something like this. There's still this issue of a bit of an excess of parentheses. And Self had one solution for that. We're doing a slightly different one, and I'm going to show it to you simply because then it'll be easier for you perhaps to see some of the syntax in later examples and to understand. So the idea is basically, instead of T-colon, write T-double-colon. That's not a new selector. That's using the selector T-colon, but it lowers its precedence such that you don't have to parenthesize. It's just a syntactic sugar. Basically, typically wherever you would write an assignment in Smalltalk code, you're going to write this. So with those small syntactic adjustments, we can compare this, and you can see that I think it's compelling, right? This is a lot more precise. And that's part of the necessary surface machinery just so you can make everything a message send. Now, why do you want to make everything a message send? Well, there are a lot of reasons, and we'll get to them. One of the more obvious one is this notion of representation independence. Right? You don't care. Once you've done that, no code anywhere cares what representation you've chosen for your instances. Right? In Smalltalk in general, most code doesn't care because it's talking to an object through the message interface. But your subclasses care and have to be refactored. If you do this, essentially what happens is that your subclasses are also, you're talking to Self through a procedural interface, a method-based interface. You're not talking to Self by accessing specific variables or anything that depends on that object. And therefore, your subclasses don't depend on your representation. And in fact, even the code in the class, there's no code. Even the code right next to this in the class doesn't depend on it. Even in the same class, you go through that interface. And so you can change it, nothing ever needs to be tweaked, or the source code doesn't need to be edited, and in a decent implementation, nothing needs to be recompiled, etc. So that's a point that's been made many times in Self again. You'll see a lot of the second biggest influence on this language beyond Smalltalk is Self. But as we'll see as we go along, this actually goes a lot further. Now, one implication, if you will, of making everything a message send is you're going to have to start thinking seriously about access control. So in Smalltalk, all messages are public, and your mechanism for encapsulating things is putting them in an instance variable. or worse, sticking them in a block, right? If you didn't have instance variables encapsulated, then you're down to sort of JavaScript style where essentially they think an object is a hash table. And therefore, the only way to actually hide anything is to put it in closure. And that's possible, but that's programming essentially at the level of lambda calculus, and it gets fairly tedious. But once we've made everything a message send, we really have stepped into this puzzle, right? Essentially, we've gone and drilled a hole in the travertine wall. Unless we do something more careful, it's very easy to unbalance a language. So essentially, we're going to have access control on messages, right? There'll be messages that are public, they're the ones you know and love. There'll be messages that are protected that essentially, in the first approximation, can only be sent to self. And private ones can only be sent to self in the context of the class that we're defining. It's a little more subtle than that, but that's basically the idea. Which means that you can actually control the structure of your interface without having to decide, am I going to put this in a method or not? That's a nice thing, and it's a necessary thing, and it leads to other things. Now, before we go into more details, we'll go through the other major points. Static state. Well, why is this a good thing to not have static state? I mean nothing. No globals, no class variables, no pool variables of any sort, and no class instance variables either, because if your classes are out there available to you, if they have class instance variables, they're stateful. Global state is a bad thing. Static state, any state that persists in this way, is a really bad thing for a very long list of reasons that I probably don't have time to go through. But basically, the absence of static state simplifies your life if you're doing distribution, you want code to be reentrant, if you're doing testing, depending on the kind of environment you're in, it can simplify your startup performance, your memory management, all kinds of things. What I want to talk about is this guy, security, one of the three imperfections we mentioned. So how does static state relate to security, and how do we deal with security? And I'm not claiming we built a secure system. That's by no means, that's no small task. What we're doing is building a language which gives you a good foundation to build secure systems. So capabilities are one of those golden ideas from the great age of computer science, which most of the world doesn't use, right? If you have a party and you don't want gate crashers, you can put someone at the door, and there's two things they can do when people come in. They can check if the person coming in is on the list, on the guest list. That's what the world usually does, access control lists. Or they can ask whoever's coming in for an invitation, some sort of token, a key, a capability that lets them get in. That's essentially the notion of capabilities. It is a perfect match with objects. And there's this, this is something that I've been thinking for a long time, and thankfully there are people who work on this full time and have elaborated on this. Mark Miller, who's now at Google, has written a lovely thesis about this, what he calls the object capability model. And they're essentially, the ability to do anything that matters, anything that might be harmful or affects the state of the system, and therefore needs to be controlled by security, depends on you having an object that can do that particular thing. Right? So the first approximation, in his systems actually the object graph really defines what authority you have. If you have a pointer to an object that links to some other object that can do something, you can do it. That's because there's no access control on the objects in that model. But essentially that means that there can't be anything ambient in the environment. For example, having a class called file that you can just send a message with a string, and which denotes a path in the file system. And then that thing will open that file for you and let you read it or write it or erase it or do anything to it. That's ambient authority. That's something that anyone in the system, in the language can do, mobile code, whatever, unless you go to some special measure. That's a security problem. You want it such that somebody has to be handed an object that knows how to open files, or perhaps better, an object that knows how to open a certain file. And that's the only way you're going to open a file. And that's sort of the core idea of this model. And ambient authority comes from static state. So we don't want static state for security reasons. That's well established. Access control helps us with security as well because it makes it easier to program this. Now, in a Smalltalk system, of course, there's a much bigger security problem, right? If you can take any object that anyone handed to you, get its class, change the class's behavior, change its methods, inspect instance variables, all the lovely things that you can do in Smalltalk. Well, it's going to be very, very hard to argue that you have a secure system. On the other hand, we don't want to throw the baby out with the bathwater, right? Clearly, this is one of the key things that makes Smalltalk wonderful. And one of the issues in Mark's work has been that, yeah, they designed this language called E that used the object capability model, and oh, there's no reflection, because, well, that's kind of insecure. Well, I don't find that terribly interesting. Fortunately, again, taking inspiration from self, there's this notion called mirrors. Mirrors are objects that reflect other objects. And in self, and in Smalltalk dialect I worked on at Anamorphic, for example, in Strong Talk, there was this notion of a mirror, which is how you did reflection. In order to reflect on anything, you needed a mirror. And therefore, just having that object in itself does not automatically give you that authority. Whereas in most systems, like Smalltalk, or Java for that matter, and what little reflection it can do, having the object gives you the ability to reflect on it. Because the object will tell you its class, and its class that tells you all kinds of information. That's a bad thing, and there's a whole OOPSLA paper in OOPSLA 2004 that Dave Unger and I wrote that explains this idea in great detail. It's a good thing for security, for deployment, for distribution, for all kinds of things. And you can therefore design an API where you can exercise very fine-grained control about who can reflect when. If you want to, you can not give people any kind of object that can manufacture mirrors. And then, well, you're kind of in Fortran land. You can't do squat. And that helps your security a great deal. You can give them mirrors that can only do certain things. Maybe they'll let them introspect, like in Java, so they can find out what's there, but they can't change it. Or maybe you can give them the full deal, and they can do everything you want to do in Smalltalk. Right? But you can control this. Exercising this kind of control and limiting what people can do is necessary if you want to have any real notion of security. It's a small world after all kind of attitude is very nice for education and stuff. It doesn't cut it when malware's involved. So that's kind of an overview of static state and security. Things get interesting because we allow classes to nest. And really, I believe that this is an oversight in the original Smalltalk. If you actually went with the clean systematic approach all the way, this would fall out automatically. But it didn't, and that simplifies matters a good deal. But it turns out that there's enormous power in doing this. And this is an idea that comes from the Scandinavians, from languages like Veda and so forth. And if you've encountered Java nested classes, don't think about those. It's different. This is going to be the key to modularity. Basically, we're going to use classes and modules, and we're going to let things nest together. So now it's time to actually show you something that runs. So this is our current implementation. It runs on Squeak Smalltalk. There actually is starting to work a native binding of the GUI set, so it doesn't actually have to live in this fake little window. But at the moment, the native binding is PC only. You'll have to live with Squeak and its windows. Like our short-term goal is to run this on the Squeak VM without the baggage of the Squeak environment around it. In any case, what we see here is a browser that has a class called combinatorial parser. I'm not really going to be saying a lot about what this class does and works. Basically, it's a parser library, and I already talked to someone who's already used the ideas from it. There are other talks that discuss parser combinators and why they're a great thing. This is just going to serve as a nice example of a module. So the entire library consists of a bunch of classes here that are nested within this outer class, combinatorial parser. So it's sort of doing packaging for us. And you might notice that these are not your father's Smalltalk browsers. These are new browsers that Vasily Pico has done for us, and there's a talk after lunch where Vasily will explain this in a lot more detail. And I encourage you to go. It's a much better talk than this one. So let's look at one of these nested classes, right? So I can open this in place, in context. and I see this class alternating parser that's nested in the surrounding class combinatorial parser. It's just indented a little bit. So alternating parser has a bunch of methods, it has a bunch of slots. Slots is the self-terminology for instance variables, and since a lot of the things about the slots work the same way as they do in itself, we use that terminology as well. And what can we see about this class? Let's look at the definition in a little more detail here. Is this big enough for everybody to see, by the way? Okay, no one complains, so that's good. So we've got a class, it's called alternating parser. It's got a superclass called combinatorial parser, and it's got 4 slots. Now, the slots are written between vertical bars, just the way you're used to writing temporaries in Smalltalk, right? Essentially, all slots are written this way, whether they're in a method declaration or in a class. Basically, we have here the list of these 4 slots, just like temporary variables. The thing about them is, of course, that there's no way for you to access these variables directly, right? You get accessors defined automatically. So for every slot like pfun, there's a method called pfun that's automatically defined. It'll give you the value that's stored in that storage location. All this does is declare a storage location. There's also pfun colon that takes an argument that'll let you set that slot. So there are lots of Smalltalk environments that'll let you, generate accessors automatically, but they won't guarantee that everybody's using those accessors. And in any case, that's one extra step you have to take. So now, given these slots, we know that there are actually accessors that aren't explicitly defined. There are methods here that are magically defined for us that allow us to access. So far, not very much happening. But let's look at the surrounding class now. There are slots right here, but there's something else going on here, right? There's some sort of, it's more than just a slot method. So let's look at that definition in more detail. Again, the slots are between vertical bars, but they are being initialized. So this is not a Boolean expression saying that this is equal to that. This is the declaration of a slot. And the declaration in this case says that I have a slot called block context, and when an object of this class, combinatorial parsing, is created, it'll be initialized. The slots will take on the values given by the expressions to the right of the equal sign. And the equal sign, by the way, tells me that these are read-only slots. Right? What that means is I'm only going to manufacture a getter method, a method that actually gets the value, in this case block context or ordered collection, etc. But I won't have a setter method. And since there's no way to speak to the slot directly, there's no way to set it, unless you go reflective with a suitable mirror if you have one. But in your base level code, you cannot actually change it after it's initialized. So it's a read-only value. The other interesting thing that's going on here is these are all the external dependencies that this module has. Because a top-level class does not see any surrounding scope. Every name that you use in that class has to be defined in that class or inherited from its superclass. So there's no global scope for you to go off and small talk that you find these things ambient in the environment. And what that means is that you're going to have to get them explicitly. And the environment can make this very easy for you, but the point is you end up having listed explicitly what this code depends on, which in a typical Smalltalk environment is one of the weak points of trying to find out in this vast sea of objects who depends on what. It doesn't work very well in Smalltalk environments, I'm sorry. And so, how are we actually initializing these? Where are we getting them from? Well, it seems we're sending a message to something called platform, which is supposed to respond to a message called block context by giving me, presumably, a block context class. Where does platform come from? Well, this whole section here is parameterized with respect to this message pattern up here, using lib:platform. And the effect of this here is to associate with the class combinatorial parsing a class method using lib:platform that you can call, right, a factory method on the class. And it will see to it that a new instance is created and this code here is executed. The slots are initialized with the code in here. And these things will be able to access the value of the parameter through the name platform. So, number one, we actually have a modular structure here that defines the interface, right? This module can't see anything unless we've explicitly told it how to reach it. And so we know what our external dependencies are. The other interesting thing is the objects of these, the instances of this definition, the actual modules, they have no access to the outside world except through the parameters passed here. So these parameters act as capabilities. If you pass a platform object that doesn't want you to ever access a file, you pass an object that doesn't support the file message, and there's nothing that this code will ever be able to do to your file system. Right? Every module intrinsically runs in its own sandbox. But we haven't had to invent class loaders and all this stuff, right? It all follows out from actually giving you the right objects, the right capabilities. Now the third thing to note is, of course, since the module definition is a class, obviously I can make multiple instances. And I can run these instances side by side and provide them different sets of parameters. So I can give them parameters that, for example, provide them only with mock-up test classes, or that log everything that's done, or give them alternate implementations of ordered collection with different algorithms and things like that. And they can all run simultaneously, right? That's side-by-side deployment. The fourth thing that you would note is, again, because there's no state in combinatorial parsing itself, the class is stateless. There are no class instance variables, there's no ambient state, no static state of any kind. Essentially, all the code in that module is inherently reentrant, right? Because the multiple instances will not step on each other. Every copy of the module, every instance I make, has its own set of slots, independent of each other. That's a good thing as well. Someone have some water? I'll steal that one. Thank you. Now, of course, since we do have multiple instances and everyone's talking to this module through a particular these objects through message sends, we can have other implementations which obey the same protocol as this class, which do things differently. For example, this is a parsing library. There are different ways you can implement this. This is kind of a simple and elegant implementation, but it's rather slow. You can have a thing called a packrat parser, which is more complicated and much faster, but also uses a lot more memory. But it can actually provide me with exactly the same interface, so I can plug in different kinds of parsers. So I can basically have alternate implementations of these modules, right? And it should be clear here, by the way, the way you access these classes is through message sends, right? So here, for example, we send a message for block context. Here, for example, we send a message to the platform to get a collections module, and then ask that for ordered collection, which again, we sent it the message and got that class as a result. All these nested classes that are listed here are accessed by message sends. So the object actually has the API, the protocol of the object consists basically of a set of classes that you access exclusively through this. And you can implement different classes to do that. The other thing to note is since these classes are accessed via message sends, these message sends can be overridden, right? So, let's find somewhere where we overrode them. So here's a subclass of combinatorial parsing. And it has overridden some of these classes. It's added a few classes and overridden. For example, alternating parser was overridden, combinatorial parser was overridden, and sequential parser were overridden. All these three guys were over here. Sequential parser, combinatorial parser, and alternating parser, right? They were all here in the class. So, we can override them. We've also added the other class, there are a bunch of classes here that are new that we've added. And let's look at one of these overrides just to see how this works. So combinatorial parser is now defined differently, right? It's defined to be a subclass of a thing called super combinatorial parser. Where does that one come from? Well, it's up here. And it's a slot that gets initialized to super combinatorial parser. That is, when I create a blockless combinatorial parsing instance, I'm going to initialize this super combinatorial parser slot with the value of the message combinatorial parser defined in the superclass, which will give me the original combinatorial parser class that I had. So I'm extending it as a subclass right here. And I think to understand how this works, the nested classes, they're access to via messages, and they're created lazily and cached. So the first time someone has when you have an instance of blockless combinatorial parsing, the first time you send it a message combinatorial parser, that's when this class will actually get created. And to create it, well, all the information we have the messages, we know what the slots are, and so forth. What else do we need to create a class? We need the superclass. And the superclass will be done by a message sender, right? We'll send the message super combinatorial parser, which is the accessor for this slot, and we'll get the value that's in this slot, which will happen to be a combinatorial parser. How did we get the original one? Well, when we initialized this, right, we sent this message. And that would have gotten us combinatorial parser here. And combinatorial parser happens to be a subclass of object. Essentially, if we omitted this, that would be fine. That's the default. But that means that we're going to send the message object to ourselves, capital O object. And that's defined in object and inherited, so that you can always get the object class to define class hierarchies from that point on. So all this would be created, this class would be created when the instance was initially created, because it's in a slot that gets initialized, and its subclass, subclass will be created on demand the first time. Now the interesting thing, of course, is that this override will affect the entire library, right? If we go and look at the original library, we inherited a bunch of classes from it, right? We've only overridden 3 of them, and we've added a few, but there's a lot more of them than we inherited. So let's look at what happens to one of them when we inherit it. So this class happens to be a subclass of combinatorial parser. Now when I ask the subclass for its wrapping parser, this class will be constructed at that point, and to get the superclass, it will send combinatorial parser to itself, which means I'll get the new overridden combinatorial parser, right? So the entire library, entire framework will be reconfigured to use the changed definition that I modified in the subclass. This works exactly the way method overrides work with methods, right? If you have 2 mutually recursive methods, if you override one of them in a subclass, the other one will use that when you execute it, even if you haven't overridden, right? So I can take whole libraries and whole frameworks here and modify them in small pieces, doing inheritance at the level of whole class hierarchies. Another thing to notice here is, well, given what I've just said, it should be clear that when I compile wrapping parser, when I compile this definition, I have no idea who the superclass really is, right? It's a message send that's going to be different at different times. It could change because I've overridden it. It could change because it's actually coming from a slot that's being provided as a parameter to the instance, and so forth. And that means that every class has to be compiled as a mixin, and is usable as a mixin. So you can actually plug it into different class hierarchies, and we provide support for that. So, here we are. Now, I think I should do, maybe I don't know if I want to belabor these points, but we actually have slides for all these points just to highlight the issues of modularity, right? We basically make all the external dependencies explicit. Every module is its own sandbox. We can do side-by-side deployment. We can have, all the modules are re-entrant. We can have multiple alternate implementations of modules. We have class hierarchy inheritance, and we have mixins. Now the implication of what I've said so far is that the nested classes are different for every instance of an outer class, right? If you think about it, when I had blockless combinatorial parsing, clearly it had a different alternating parser. I overrode that. But when I looked at wrapping parser, it turned out that one was different too, because its superclass depended on those bindings. So I have a different wrapping parser here, in this guy, than I have in this guy. And what's more, this could be, this has to be per instance, because I could, in principle, have these classes depend on a parameter to the method that actually manufactures the instances. So every instance of a class that contains nested classes has its own set of nested classes. This is the way it was done in beta, by the way, almost 30 years ago as well. This is semantically the right way to do it. It's not the way it works in Java. When you do nested classes, you actually have to understand what it is you're trying to emulate. So, that may not have been obvious. I wanted to make that point. Now, there are back pointers from these nested classes to the instance with which they are associated, right? This instance has its own set of nested classes, and each of these knows about this object, and that object is called its enclosing object, okay? And if we look at one of these nested classes, it could certainly have any number of instances, right? These are all instances of this class, alternating parser, which was the unique alternating parser class that was derived from this particular instance. And it knows about its enclosing object, which is this instance right here. And indirectly, all of these guys know about this instance. Now this is the tricky part. Here we're getting technical, arguably too technical for a keynote, but I actually hope that I can get you guys to actually understand how this works. Because it's important to understand this, to understand how method lookup actually works here, right? Because if we go back and look at some code, let's look at this stuff. I hope you can see this. But it doesn't matter what this message really does, but what I want to show you is what happens in terms of referring to these various names in the absence of an explicit receiver. So we've got parameters here, right? df1 and df2. And they're used in the code. That seems obvious. But remember, we're not actually mentioning any variables. Conceptually, we are sending a message here. Here's pf2. There's no receiver, right? We said we needed implicit receivers. The syntax just gets out of hand. Also, you'll see it makes it actually easier for you to write, because the compiler will figure out, or actually the runtime will figure out who the receiver is. So who's the receiver of pf2? Well, in this case, it's the activation record of this method, right? The method context. Because really we don't actually have to make a real method in the implementation, but conceptually what's happening is that for every formal parameter in the method, there is an accessor method that will actually get you the value of that parameter, and that's what we're actually calling here. And so the receiver here would have to be the method context. But if we look at, say, pfun colon, right, that's the setter method that was derived from the slot pfun. And it doesn't have an explicit receiver either. So where's that going to? Well, it had better go to an instance of alternating parser, right? That's the class that is in fact which this code is defined. And so it basically goes to self, right? Same thing with here. This is an example of the double colon syntax. pfun colon is again calling the setter for this guy. It's not necessary in this case, but often we do write it that way. In any case, both of those have an implicit receiver, and that implicit receiver is self. But if we look at something like block context here, right, this isn't a global variable of any kind. This is a message sent to somebody. And again, there's no receiver here. It's implicit. So where does it come from? Right? Block context comes up here, and there is an accessor method that will let us access the value of that slot. But if we're accessing that value of that slot, we're going to need an instance of combinatorial parsing, right? And this is where the story about enclosing objects comes in, right? Every instance of alternating parser knows about its class, and its class knows about the enclosing object, the object which gave rise to it. And that's where I'm going to get an object that knows how to interpret block context. So the method lookup is going to go up this lexical scope chain, if you will, to find who it has to send this to. So, just maybe didn't do that. So let's look at the lookup when you have an implicit send, when the receiver isn't explicit. When you have the receiver, it's pretty much the same modulo the issue of access control, which I'm not going to talk about today, partly because it's not fully implemented. But if we're doing a send where the receiver is implicit, what actually happens is you first go up the lexical chain, and then you go up the receiver's inheritance chain. So we start with a method context. That's sort of our initial receiver, really. And, you know, if we're talking about a variable or a local slot, that's where it should come from. And we might find it here. Now, we don't really have to do a method lookup or anything in practice, right? But that's all implementation. Now, if I was saying sending something like tfun, right, trying to get a slot of the object, I'm not going to find it here. The next stage is to go up, all the way, to the enclosing object. For the method context, the enclosing object is actually the receiver itself. And find its class and see if it defines. Yeah?
The slides are very dark, so rather hard to read. I don't know if you do anything about it.
Yeah, well, the color of the projector is, I'm not really sure what I can do about that.
Yeah, fair enough. I'll look at the slides later. So. That's letting you know.
Well, that's good, because the next time I give a keynote with this projector, I'll do something different. I'm used to PCs having really weird color problems. These guys are a little dark. What it says here is either or, which is the name of that method, an alternating parser, which is the class in which it's defined, and combinatorial parsing, which is the next class. And this is object. This stuff doesn't really matter. These are the superclasses of this stuff. Okay? So the lookup will proceed up essentially the lexical scope chain. It'll look in alternating parser. It won't look in its superclasses. It'll see if alternating parser itself has an accessor. Because what we're looking for are things that are in the lexical scope, that are actually visible, defined in that same lexical definition. And we might find our accessors qfun and bfun here. But if we're looking for block context, we're going to have to go further. Right? We're going to have to go up to combinatorial parsing. That's the outermost lexical scope. And there, we will find that it has an accessor for block context. How do we actually know that this was going to be combinatorial parsing, right? Looking at the code, it's obvious. For you, the programmer, right, its lexical scope is right there. The machine actually doesn't know that. What the machine knows is that this alternating parser class, which I was looking before and couldn't find anything, has an enclosing object. And I go to the enclosing object, check its class, and if I find it, I know that will also be the receiver, right? Once I found the method, I actually have to invoke it on a particular object, and that enclosing object will be that message. Now let's suppose I was looking for dictionary instead of ordered collection or block context. Well, it turns out that we didn't define that in that code. And so the lookup will continue. At that point, I'll say, well, it's not in the lexical scope, right? I've gone up all the way to the top of the lexical context, and I haven't found it. So then I'm going to interpret it as a conventional self-send. And that means I'll start going up the inheritance chain of the original receiver. And I'll go up the usual way you're used to through a superclasses combinatorial parser, and then I'll go to object, but none of these will have a dictionary, and eventually I'll do the does not understand the usual thing that you do this one. Right, so that's actually how implicit method lookup works. It's actually, this is a little simplified because the mix-ins make this just a little more interesting. And to make this work well, we actually had to add some bytecodes to the VM. Yes, Colin?
One question. If you don't find it looking at the superclass chain of the receiver, do you then
No,
look for the
no,
other?
you're not going to do the zigzag thing. No.
Okay.
So are you saying that that the lookup has a root priority over a branch priority? You look up the root.
Yes,
then you go
that's
branches.
different than say in self or in beta or whatever. The reason for that, I didn't mean to speak about that, but since you're asking, if you think about what happens when someone then goes and modifies something in the superclass, right? In a superclass of something, if you wrote one of these things and referred to something in the lexical scope in a nested class definition, and then the superclass of that nested class added a method that actually responded to that message, if you do the zigzag thing, you do the classic thing that self does or beta does, it'll capture that. And you wrote code thinking you were calling something that was clearly visible in the lexical scope. We think that's just the wrong answer. Okay, so now you know how, kind of know how method lookup out. If you're really interested in this stuff, think what happens when there are mix-ins and realize there's a bit more to it. But in any case, you can do this in a standard Smalltalk. The first implementation did this. It looked at the context and started fishing around. It's much more efficient if you do it in a bytecode. So we've added bytecode to support this kind of thing. Now, there's something no one's asked, which is fine, which is, okay, if these modules don't see any surrounding scope, how do I hook them together, right? Each module is very well isolated, and we've argued why that's good for security and all that stuff, and lack of static state, but eventually you're going to have to plug them together, right? But you can't write a module to do that because the module can't see the other modules. And so there are different ways of doing this, but conceptually they're all the same. In this case, this is what we call an object literal, and it isn't actually implemented yet. But this is how it will work. At the moment, it simply works through Smalltalk workspaces, right? We can use those to cheat. We can use those as a scope where we do see all the modules. But and you can imagine an environment which lets you do that. And then you'd write code that hooked it up and put that in an object. But language-wise, it's cleaner to have the language. You have self-sufficient support for that. An object literal would be an object that basically had something that looked like a body of a class, right? It would let you define nested classes and methods and all that. But the classes would still be modules, right? That's why I was very careful saying that a class that is not nested in another class is a module, right? We want classes to control the scope. So we could define some random app here as a module within this object. And what we'd likely do is provide it with this object with a main colon method that took of a platform as an argument. You'd give it an object that gave it its connection to the outside world. And then in that code for main, you would actually hook up your module however you want to, or if you have several modules that you define here, then you hook them up. And so this thing will work a lot like the way C programs start up, right? A C program, what is a C program? You load some piece of data and functions from the disk, and there's an agreed entry point that the system calls and things start working. The difference here is you load an object, if you will, from the disk. You can serialize it and load it back, and then you call its main method. And unlike a C program, right, you don't have pointers from this object going to millions of places, right? It's everything that's connected to the outside world has to come from this argument. In C, only the command line arguments are passed in this way, but the actual thing that you're loading can have static links to any number of libraries and things that you brought in. Here, everything comes out through this parameter, which means that, again, you can sandbox it. You can deliver mobile code this way, load it, and control what you're going to allow it to see and how much you trust it. So the general schema for these things is you've got an object literal, you've got all your module definitions, you've got a main colon method that then takes some object representing the platform and uses that as all the code to actually do the linkage between your modules at runtime when it starts up, when you call this the first time, and invoke the complete application. This is actually an example of this with our compiler, which consists of basically a bunch of modules. So there'll be this combinatorial parsing module, which actually nested inside this thing, and blockless combinatorial parsing as well, which you see. And then we have a grammar for Newspeak, which uses this parser, which uses a parser library. It actually needs to have some sort of library because the grammar is defined with respect to this library. We have an AST. Then we have an actual parser, which requires the AST and the grammar. Then we have a compiler, which requires the parser of the front end, requires a mirror library for reflection, and general purpose stuff from the platform, like dictionaries and collections and stuff like that. And this didn't fit on one slide, so on the next slide you have a main method, and there we'd actually use these modules and hook them together. We'd actually create a blockless combinatorial parsing of the platform. We create a grammar with blockless combinatorial parser with a module we just created named parser-lib. We create an AST module, which also needs a bit of a platform. Then we create a parser using the AST module we created and the grammar we created. And finally, we create our compiler module using the platform, oops, I'm cheating away, and the parser module we created, and we get the mirrors from the platform. Right? So you actually do linkage among all these modules explicitly through their factory methods. And you do it all here with respect to a parameter that will be passed to you when you actually deploy this. So that's kind of our modularity story, which is a lot stronger than any modularity story that I've seen anywhere in the academic literature and certainly in mainstream programming. Then there was this third flaw, which was the issue of interoperability. So let's talk about primitives, right? You're probably the only audience in the world that will actually recognize what this stuff means, right? So there is this notion of primitives in small. And isn't it nice to explain it to someone who isn't a small? Doesn't your chest sort of swell up with pride because it's such a beautiful and elegant construct, right? Depending what the primitive is, you can or cannot make up a story as to who the receiver is. In this case, it's rather tenuous, the connection between it and its receiver. So after you've just gone and told them everything's an object, they all send messages, blah blah blah, and they stumble upon this, which you were careful to try and hide from them. You lost one more convert, right? Why am I talking about this? Well, I'll explain in a minute how this connects to interoperability. But before that, I'll mention that we don't do this, right? The syntax is gone. There are no primitives as such in Newspeak. It doesn't fit with the idea that everything is a real message send. What you want to do, what is a primitive really? It's a request from the VM to do something that I can't do in the language as usual, right? So it's a message to the VM object. The VM object is something you don't want everybody mucking with, but it should be reified via mirror. Again, it should be an indirection of via mirror that some people will be able to get at, and some people won't. You want to control who can do this, because otherwise all is lost in terms of security. And the language should actually have a standard API for this, so that you know what primitives you can count on and what is portable. So that's again taking the notion of object seriously when message passing seriously when we're talking about primitives. What does this have to do with interoperability? Well, primitives and foreign function calls are usually intermingled. In most languages, primitives are foreign. That is, if you're writing a Java VM and you want to call something that the Java VM can do for you, well, Java has a mechanism for calling C. And the common assumption is the VM was written in C or C++. And so you use the mechanism for calling C to call this particular C function that you're linked with and you know that comes from the VM. And this is very tempting to do, but it's very wrong-headed. It's wrong-headed because these two notions of foreign function call and primitive are actually distinct. For example, with foreign function calls, there's no end of issues of marshalling, of how to package the data and how to present it and so forth. The primitive doesn't have to worry about. The primitive is a primitive of your VM. It knows all about your data. It knows far more about your data than you do in terms of its physical formatting and so forth. So it makes sense to have them separate. The other thing is, of course, this assumption that calling the VM is a foreign function. Well, who said it had to be in a foreign language, right? It could potentially be done in a different layer in a high-level language. And people are doing such things. So, in Smalltalks, of course, it's the other way around for historical reasons. In most Smalltalks, the foreign function call facility is some sort of variation on the primitive facility. And they come with the same ugly syntax, and they're all done as an afterthought because they weren't there in the original Blue Book, and they're kind of non-portable and so forth. So we want to have a way of calling foreign functions that is natural, clean, and easy, and guaranteed to work the same in every version of the language. We do this by sending messages to aliens. Alien objects are objects that represent foreign functionality, right? So think of a DLL, perhaps, right? What is a DLL? That's another object. It's an object that's, we will provide you with a facility to load it and wrap it up so that you can talk to it as an object. But you don't have to write some special funny syntax, and you just talk to it as an object. Somebody has to know, right, at the lowest level, how these things are laid out and how the marshalling are. There's several levels of alien API. The nice thing about this approach is since you have objects per, you can also have different alien APIs for different languages, right? People usually focus on C, which of course you realistically have to have, but if you actually want to conveniently talk to Objective-C, it's different. If you want to conveniently talk to Java, it's different. If you want to talk to .NET, it may potentially be different. You can have an alien API for the particular planet from which your aliens come from. So this approach kind of scales nicely without having any sort of external, any kind of built-in support in the language. And then we can do interesting things. For example, we can get rid of this hokey squeak API. No offense, but it is. Try explaining this to someone in the corporate world why you're using this. You'll find that never mind. So this is actually the same kind of browser I've been using in demoing this stuff, right? This is our browser running in a Windows window with a Windows scroll bar and Windows text thingies and Windows fonts and so forth. And this goes over much better, and eventually there will be such a thing on a Mac as well. And so to do this, you need a real foreign function API that's reasonably performant, that lets you do callbacks and all these things. And then you can make, you can reduce the gap between you and the rest of the world. Now I know there are small ones, of course, that have native APIs, but they're either native or they're not, and specific to a platform, or they're kind of rather fake. Right, and in the extreme case like Squeak, they're totally, just in their ghetto, a little bitmap square. Right, so you want to do this because you don't want your Smalltalk applications looking like something out of another world. At the same time, you do want them to be portable and run in different places. So this browser code, not a single character of it, of the application code that builds this Newspeak IDE, has changed between the Windows version and the Morphic version, because all of that is taken care of at lower levels. And again, Vasily will be talking after lunch to explain all that. So that's kind of working for interoperability. So those are the three imperfections, and they relate to the three sets of issues that we have learned since 1980. And I'm going to show you why we've done things a little differently and how we can actually address them. Now, we also said that the world has changed. So if we want to talk a little about those issues, we're not going to talk much about multi-cores, it's not clear, but it's clearly some sort of concurrency story that's more suitable for the world we're going to be living in is necessary. Actors are, again, since 1972, Carl Hewitt figured all of this out, with Stone Age tools, basically, right? Nothing that's been done since has actually progressed this very much beyond that. Right? Actors are a natural fit with a language like this, right? Just add a thread of control to these objects, and they communicate via message passing, and this time we're talking real asynchronous message passing. That's where we want to go with concurrency. Basically, I don't believe that concurrency and shared state should be mixed at the application. Right? If you're doing some fancy system programming, maybe. Otherwise, it's all in.
Have you thought about the concurrency model that he uses?
And who uses? Yes. Just as the security model is not very unlike E, the concurrency model, we haven't done anything on this, so I'm not going to commit to that. Looked at that, that's something along those lines is a distinct possibility. At this point, what I'll say is the core belief that I have that we'll go with is some sort of actor model, right? What exactly it is, whether it's E-like or not, we'll have to build it and see. It's more likely to be E-like than Erlang-like, frankly. Then there's functional programming, right? So those guys have been promising the world wonders for, again, 25 years, and they just may be at the point where they may be able to deliver. So I've hedged my bets on this. If you look at this language, you'll find that you can write code that is parameterized by the platform that it's going to run against. And so if you have a set of functional libraries, you can write pretty much functional code. In particular, if you insist that all your slots are immutable, that is, you use only the equal sign, you don't make mutable slots at all, you're pretty much in a functional language. Now, there are issues of reflection or whatever, but at the base level, you're in a functional language. There's still a little trickiness in the initialization, and we need a letrec construct, but I'm not going to get into that. The point is, it's very, very easy to migrate this language just a little step further and have a functional dialect if you have functional libraries. That means functional libraries all the way up to top, because object has to behave differently, right? Equal has to be different. Things like that. But really, again, I keep coming back to what I want to talk about is this interweb thing. So, how do I see this fitting in? Why do I think that there's a need for doing things a little different in this network age, this kind of design might be helpful? Well, everybody's talking about cloud computing, and the clouds refer to the hot air vapor that is emitted by the various discussing this, and I just wanted to add my bit of vapor. So the other interpretation is actually that the cloud, everything's going to change after the cloud. It's the Big Bang. Nothing will be the same. And so perhaps, God, it is dark, but it is dark anyway. So maybe this is the cloud that they have in mind. I don't know. But in any case, cloud computing is a lot about delivering software over the network and making it easy to maintain and so forth. And the likely channel this will take is that, everything comes through a web browser, so the web browser is your excuse for an operating system. And JavaScript is the assembly language of that machine, of that internet virtual machine. Okay, that's nice. Different interpretations of this are possible. So, a lot of times it seems that this is basically, we're going back to time sharing. Right? It's the cloud, the supercomputer, Google's machine out there in their data centers, and we just hook up to this, and we use a terminal like this. This is a CTC 6000, a machine in which I had the privilege of working on over a 300 baud modem way back. And so are we going back to that? A lot of people at Google sort of think that, even though they do other things, they've done Google Gears because they realize that it isn't that way. But a lot of them still, they want to be the CDC 6000 for the planet. So I don't think so. Of course, there's all these things that don't work well as a web app in this way, right? The operating system, the web browser, all the plugins that do your audio, your video, there's all kinds of software that has to be on these rich clients or whatever you want to call it. UI, well, it depends, right? It's gotten a lot better with Ajax and so forth. It's still incredibly painful to program, but Google Earth, is this going to really work that well? I mean, it all depends, of course, on what kind of network connection. So as long as you have a reliable, robust, very fast, and essentially free network connection, that's quite possible. It's often not free. It's often not fast enough, depending on the kind of applications we're doing in Cadence or things like Google Earth, right? It isn't fast enough to do it that way. And sometimes it's just not there, right? And so what are you going to do? What are you going to do with your critical data if you can't access it? It's all out in the cloud all the time. Another point, which is one of my pet peeves, is, right, I hate things that reboot. I don't like computers rebooting. They shouldn't really reboot visibly, right? You've got 300 milliseconds below the threshold of perception. That should give you all the time in the world to reboot. Right? If you feel a need to reboot, please be discreet. It's gotten worse, of course, because now my phone reboots. My television is starting to reboot. Everything is, we're going digital and going digital in the wrong way. On the web, you reboot as well. You can't actually leave your thing open and come back to it, right? Because they're going to throw you out. The session will expire. The session expires for good economic reasons. The cloud model means that they're paying for your computing time. And therefore, they want to optimize that, and that drives all kinds of things. It drives them to code in C++. because they're worried about their electric bill. I'm not making this up, right? Talk to people who they have these issues. It actually is driving them to low-level programming because the computing factory does so much computing, it's worth that optimization. And your machine can sit there, you know, displaying, you know, little windows in the web browser. And that's sort of the vision they have. That's one of the reasons I don't think this works. There's a very strong economic incentive to actually make use of the computing power of the devices on the edge. So, if that doesn't really work that way, what can we do? We can do what, there's been millions of terms for this stuff, smart apps, fat apps, rich internet applications, whatever, right? I'm calling them network service applications. To be more specific, to be the variant that I'm trying to explain here, where you want the advantages of the web services without the downside. So you want to combine the best of both worlds. And that means it's always available. Always available means always, even if there isn't a network, where you're not prepared to pay $10 for an hour from some hotel that's ripping you off. It means, on the other hand, it is always up to date. That is modular of the network, right? You want it to update every time. You do not want to see versions of stuff. You don't want to know about, oh, the next release is coming out, and do I, you know, both as a developer, you don't want to worry about people running old versions, and as a user, you want to get bug fixes, you want to get the new features, and you don't want to have to do anything to do that, right? No one goes to Google and says, you know, your web page in 2003, I really like that, so I still use that, and you have to maintain that until the end of time, right? They can't do that. They don't even realize they can't even ask the question. That's the best thing, when you said it so obviously that people can't even conceptualize the stupid question. So you want something that runs locally on your machine, but is connected globally and can take advantage of it. And yeah, I don't want it to restart. So we're talking about software services, again, clouds, all these buzzwords, but we're talking about a particular version, where yes, you keep your software and your data backed up on the server, right? It's nice to have reliable backup. It's nice to have an audit trail. It's nice to be able to find out what was there on April Fool's Day 2004 or whatever, right? But on the other hand, you run it and get it downloaded to your machine, and you have a cached version of that so you can run offline. And every time you connect to the network, you can sync it up. How that sync works, it can be done every 5 minutes, or it can be done on demand, or there's different ways of tuning this, and there's issues around that. But ultimately, you're syncing the data and you're syncing the program, right? Programs is data. And when you sync, you don't have to stop everything and restart. Now, what kind of technology might be able to do that? You might have an inkling, right? One of the things you want to be able to do is to update running stuff on the fly. You may have heard of a system that can do that. On the other hand, it is very useful to have well-defined units of deployment. What it is you're giving to a particular subscriber, bounding that object graph. That's why modularity is really important. So while Smalltalk is really strong on this, it's not so great on that. Since whenever you're talking about mobile code, it's probably a healthy idea to start worrying about security. And then there's this notion of orthogonal synchronization. And my one is in gray. Here it looks the same. Anyway, the reason it was in gray and had the stars, we're not ready to show that. We're kind of playing with that idea. The idea of orthogonal synchronization was to make it easy to run applications that will actually work for users in this way, where they have their data running on their desktop and they want to synchronize the data on the server that maybe someone else has updated, or they've updated from their phone or whatever, and make it easy to write that application without the application developer going through special hoops, making it a systemic property of the system. That's something where we hope to fold into Newspeak at some point as well. And then, basically, you can deploy applications to people, because module definitions are objects. The namespaces that control multiple module definitions and then can connect them, as I've shown you, are also objects. And you can serialize these objects and then have the system, on the other hand, load this domain and get going, right? And that's the key idea. And you can imagine a service that does this for you, where you are a developer, you can upload links to the server and then distribute it in some way to users. So for example, if you worked at mycompany.com and you had a bunch of applications like app and demo, and you had some subset of applications under the myGrand brand, you could build an object that looks roughly like this. You have the modules defined here. You have another namespace object that has within it yet another module plus some additional stuff. And you upload this to under some name, right? You just call, you would be able to presumably get the service to upload it under a label, essentially a string representing, say, your URL. And then someone could download this. Probably the user wouldn't actually type this, of course, but the code that would do the download would presumably, again, talk to the service, give it, again, a URL for something, and that would get you that particular object. Deserialize and deserialize it over the network, and then put it in your local cache, and it would then be part of your account. And you could run that application. So the details of this are fairly hazy. I know there are some people in the Smalltalk world who are actually doing things kind of like this to some extent, and they'd like to have more support. And this is kind of the way I think a lot of software will get done, client software, in a few years. I'm hoping that it doesn't get stuck on the local optimum it is right now with Ajax and garbage. And Newspeak is a language which is designed to make that sort of thing relatively pleasant. So, where is Newspeak? We're still working on it. The language will evolve. In particular, it'll probably look a little less Smalltalk-like syntactically in the interest of pandering to the masses. But not in any fundamental way, because some of the syntax is really fundamental. Like the keyword syntax is actually fundamental in a dynamically typed language, because you can't get arity errors and stuff like that. But we might throw in some curly braces and some stuff like that, just we're not done with that, and we don't have much in libraries. We're heavily reliant on the Squeak libraries at the moment, which really aren't suitable for this ultimate vision. We're going to be open sourcing it under Apache 2.0, and we've got a lot of stuff to do on the tools and the libraries. We don't have a native GUI on the Unix box yet. This serialization format, well, we do have that actually. The FFI, we want to refine it, right? We can't call it Java right now. It's all devised for all these awful platforms out there. We haven't done anything on concurrency. This is a hard problem, and we're still researching that. There's a bunch of little features here that have to be implemented. This turns out to be easy. This is very hard. These are hard. This is actually quite a challenge because this language, I have middle type checkers for Smalltalk, optional type checkers, right? We don't require you to type check, but are handy. This is harder than Smalltalk because it's that much more dynamic, right? At least in Smalltalk, when you have a class, you have a class. Here, all you have is something that sends a message, and you don't know what it's going to give you. Overall, I guess the big picture is that we found that there's a synergy between a bunch of concepts that really fit together, so we don't need very many. Message-based programming is central. That works very well with component-style modularity once you do this notion of nesting with classes. And you get virtual classes, mix-ins, class hierarchy inheritance, all that fits, essentially falls out from that. The object capability model also works well with this, and apparently it synergizes beautifully with this because you get sandboxes for free. Mirror-based reflection works very well with the capability model. It's essentially one of its properties. We believe actor-style concurrency will work this way. We believe polygon types will work this way. It's at the bottom of the list for a reason. It is at the bottom of the list, but it is still a useful thing to have. And so that's the story of Newspeak. And just a few minutes for if anyone has questions. Otherwise, thank you very much.
You mentioned the possibility of the syntax sugars being malleable at this point, not having decided on where some of that's going to go. Why not make some of that parameterized and malleable so that we're whatever type of syntax you're happy with, you change it and it looks that way to you, and you hand it over to somebody else, and they have their settings, and it changes to match what they're looking for.
Okay, so one of the things I've thought about is, in fact, having several sugars, right? You can make it ugly Visual Basic style, or you can make it ugly C style, or you can make it ugly, whatever style. Or you can use the real thing and it isn't ugly. That's a possibility. That's an untried idea, of course, because usually people expect a language to have a syntax. And so, while if you let the user control the syntax, well, I'm sorry, I don't trust the user nearly that much. I do not want to think what might come out of it. In particular, it's important that all the syntaxes really map cleanly to the abstract syntax, right? So in fact, I will be easily, automatically be able to display this routine in whichever syntax you chose, as long as they have the same underlying structure, right? You put this into the hands of a Rubyist, and I don't know what comes out. That's not going to happen. We might have several sugars, but again, I haven't really thought it out. It may just be easier to be conservative and say, here, this is the sugar we have. But that's a thought, yeah. Yeah.
I noticed that there seems to be, at least from what I understood, that you could be wrong, that there's no difference between the names that are inherited from, for Smalltalk, the Smalltalk dictionary, like the names of the classes who showed you the code, oral collection, and so on, and the slots for the object. Have you considered having those definitions be a little bit more separate and flaggable, or you decide to not do that for some reason I don't see?
Okay, I'm not sure I even understood what this question is about, but I'll try. Okay, there is no difference between, as far as usage, it doesn't matter how that message got created, how the method to handle that got defined, right? You're sending a message. It may have been defined automatically because you defined a slot. Or it may be a method that you explicitly wrote. Or it may be a nested class declaration that you wrote. Right? This thing actually has a real syntax, and you can write these nested class declarations. In terms of usage, very deliberately, yes, they're all the same. The only way to guarantee that you don't screw up is to have this uniformity, right? If you say that they're all going through this one mechanism, you have one set of rules, and things fall out, and they're harmonious and simple. If you start saying, oh, I'm going to have a namespace for types, and a namespace for expressions, and a namespace for methods, I know a language on it. I know it very, very well. I spent 10 years, and I can spend another 30 years on it, because it's a lifetime labor to keep maintaining that machinery, right? You have to keep the core definitions dead simple. Now, in terms of the global name, what you refer to as global names, right? They're not inherited from Smalltalk, they're not global, but putting them in slots, that's just the mechanism there is. I didn't see a need to invent an extra mechanism. I would regard that as a failure if I had to use another mechanism. There is a mechanism for doing this. It means that your module objects are a little larger, right? They have some slots for these important names. These module objects are rare and few and far apart. It's no big deal if they're a little larger, so we use slots to hold these things. Otherwise, we'd have to have some sort of special input. And I think it's really nice that you don't. It just falls out. And there are other ways you could get these guys, right? You could, in fact, ask them as a parameter to something else that put them in a closure. So there's games you can play. They're usually not useful as far as what I've seen.
So you could have kept it as platform slot and ordered
Right. So I could have done that, but then I'd have to, A, that's very bad style, right? Because the whole idea is to have clearly who we are relying on, and B, fortunately it makes it more verbose, so it's likely to discourage you from using that style. There was someone in the, yeah.
Looking post-hoc at a system where you build certain effective class structures under the expectation certain rules are remain, someone comes along and to the superclass starts adding messages, how easy and how natural is it for the person who is post-hoc kind of re-engineering studying that system to understand how the lookup works and or what the original intent of the user was?
Okay, so when I have a million users and some of them developers, I'll have a better idea of how easy that is to understand. The experience with beta, which had, decades of experience, was that, basically it actually does what you want. It's very intuitive. You see the lexical scope. We've tweaked that a little bit to give even more preference to the lexical scope. I believe the nature of this thing is, yes, it's fairly easy to see, to understand what it is you're going to call. The actual implementing the lookup or explaining exactly how those mechanics work, in beta was complicated, and here it's similarly complicated, right? But their experience wasn't this, they had no impact on how their developers thought, right? It's more if you have to think about how you're going to implement it, where you're going to find these things. So I'm not worried about that. Alan?
Class extensions.
Yeah, so this is, Elliot Miranda worked with us for a while until he went to Quack. And we had this argument frequently. I find that, the small talk culture's fondness for class extensions is not something I share. You end up having classes with large numbers of methods, and no one really coordinates them. No one knows if you're going to have conflicts when you load stuff. It all becomes very, very brittle, and depending on which order you did what, which extension came where, I don't believe in that. I wrote a blog post. It's called Monkey Patching. If you want to hear my full opinion on this, I'm sure many people here will not agree with it. It's a hard problem. The thing people are trying to do is sort of this eat my cake and have it too thing where, yes, I want object orientation and encapsulation and modularity, and yet I want to be able to have, in this context, I want this thing to do that or else. So there's things like class boxes. There's aspect-oriented programming is actually, another attempt to chase the same rainbow. I don't believe in any of these. I've never seen a solution that I like. Selector namespaces, that may be better than some of the others. I still don't like it. It's more complexity than it's worth. If you structure your code well, you don't find too often that there's a need for it, right? You have modules, you have mix-ins. A lot of the stuff you do in this style, you can do by mixing in something when you want it. And sure, there are some cases where it's hard, but on the other hand, class extensions give you another set of problems. So we're not going to really let you do that sort of thing. Of course, you have reflection, and you can muck with things reflectively, right? If you do that, but basically, there's a line. There are class definitions are class definitions. They're self-contained. Yeah.
Well, the system will give you the source code for base classes, and you can change the system. Doesn't meet your needs.
Well, it'll be open source, so in that sense, you can always go and do what you want. The value of the system, I believe, will be in having, having something that actually works the same across a wide range of places. Right? I'm not sure that's a good thing. You can, of course, as an individual, go and do that. It's open source. Colin?
On your slide about message lookup, you mentioned that with the implicit self lookup. Is there a difference between dispatch in the case of an implicit receiver versus an explicit receiver?
Yeah, because in an implicit receiver, when you have an implicit receiver, the dispatch has to figure out who the receiver actually is, right? It's not the same object. In regular method dispatch, who the receiver is fixed, right? In Smalltalk, it's explicitly, you evaluated an expression that told you once and for all who the receiver was. You had to find out where the method was, and you would invoke on it. You still have to do that for a given receiver by looking up the class chain. But in an implicit receiver, one of the things the lookup has to do is figure out who the receiver really is going to be by looking up the lexical chain.
Just a quick follow-up to that. Do you find that in practice when you're programming in Newspeak, you use implicit receivers so that you can do lexical dispatch for non-accessor cases?
We use implicit receivers all the time for pretty much everything. Unless it is, if it's anything in the scope, right? If I'm in a nested class, any method of that class, or any method that's inherent, that's invisible in scope, we use implicit receivers. It's both shorter and more natural. We use essentially, occasionally you have a super send, right, which is different, or you have a send to some other object, which is just a regular send of a public message. Otherwise, it's fairly rare. Conceivably, you could have a style where you use self-sends for inherited stuff and so forth. We generally don't.
So you effectively override superclasses with parent classes, outer scopes.
If they conflict, which is potential, though very rare in practice, right? Because they're usually doing something very different. But yeah, the whole idea here is that lexical gets priority because lexical is something I can see. That's what I was likely thinking about. If I really want to, if there really is a conflict, which is exceedingly rare, and I know I really want the inherited one, then I say self, right? There was someone here. Yeah.
How do you find your performance?
Okay, we're running on Squeak. So our performance is, our baseline is Squeak performance, and then we're a higher level language, right? Squeak is an interpreter. There's nothing clever is going on. Therefore, every instance variable access is going through a message send, right? That apparently doesn't seem to impact performance much. What impacted performance was the first naive implementations of this implicit send lookup. That can impact the performance a great deal as you reify the context and whatever. So we've optimized that, and now there's a bytecode, and the problem's gone away. Supersend, right? Everything's a mixin. You can't statically bind a supersend, right? A supersend actually has to do some fairly fancy dynamic lookup to figure out who the superclass really is in this case. But again, so Squeak didn't do a good job of that at all. I think most Smalltalks would not do a very great job of that, but of course your baseline performance might be better. Over time, Squeak VM, there's nothing holy about that, right? It was a convenient choice for us, a licensing fit, it's easy to muck with, it's incredibly easy to change the VM. Over time, I expect it to run on other things. Yeah.
If I've assigned this down as message sends, is return somehow message send, or is that
Yeah.
a bytecode?
So it doesn't matter whether it's a bytecode, right? That's implementation. Return has always been a kind of message send. Ask Alan Kay, he's always argued that it's been a message send, right? It's a message send to the activation frame, telling it to stop and look up, go up its sender chain. Conceptually, that's what it is. This may become more explicit as part of the syntactic sugaring, right? You get very nasty responses to hat out there in the non-Smalltalk world, right? So if it said return : and it was a message send, they'd probably digest that better, and it's actually closer to the model. Yeah.
I have a totally different question.
Yeah.
That is, what is the big picture, the commercial part of it, the vision part of it, of Newspeak and of Keynote?
Okay, so take your pick. Those two. Right? It is about making it easy to write applications that work locally but can be updated easily and interoperate with a cloud backend. And there's a lot more that can be done with that, and I've given other talks, right? It's another hour talk about what can happen when you have these things ubiquitous, how your development process can change. So commercially, well, there's a small picture of how I got somebody to pay me to do this, and then that is simply Cadence needed has an interesting application that I'm not allowed to talk about, where there seemed to be a fit, and we got them to do this, and that's working out fairly well. Beyond that, it'll be open source, and you could imagine starting up a service around this or things like that. Who knows? There's a lot of work to be done before it's at the stage where I think it'll be robust enough and all that whole picture, especially the synchronization story and so forth. But I guess that's as much of an answer as I'll give you standing here. Is that an answer? Oh, anyway, it was the answer. So I'm going to warn you all out? Pretty much, yeah. Okay, you can go to sleep again. Thank you.